All right, I want to introduce advanced task number 4, visual comparisons of two documents. You can submit it here on Moodle. Here's the code. And there are 3 files that you'll output where you'll upload as well, along with your code when you submit. So let me show you the code here. In task 4, this is one of the advanced tasks. We're going to do visual comparisons of tokens from the 2 documents at the same time. We're going to do the same visualizations, the word cloud and the bar plots. But we're going to show the tokens from both documents at the same time. So first, we're going to import tokens from both documents. So you can run through this. We're going to have the document names for or prefixes for both documents, doc1 and doc2. The files, the tokens, we're going to import the tokens from before. So these are Hamlet tokens processed and Macbeth tokens processed. So we'll construct those file names here. And then I'll read in the file for the first one. This is Hamlet, and it has 15,000 tokens. And you can view the first 10 or so, and there we go, Hamlet. And then the second one, from the second file name, and then Macbeth has about 10,000 tokens. So you can double check these, and it's Macbeth. Okay, so now we have tokens 1. We saved these tokens as this list of tokens in tokens 1 and tokens 2. So now we're going to recalculate the token frequencies. We should have saved these at the end of task 3, but we forgot. Sorry about that. So we'll do it again. To do this, I'm going to create a document, or sorry, a function called token frequency distribution. It just does everything that we did before, calculates the token frequency distribution, saves it as a tuple, and sorts by the token count. So we'll do this. This is just creating the function, and then we'll enter tokens 1 and create a frequency distribution of tuples for the first document. So this is token and frequencies for Hamlet, and then we run this function again for tokens 2. It gives us the frequency distributions for Macbeth. So now we can calculate the top 25 tokens in both of the documents, and we can identify overlapping tokens. And here, since we sorted in descending order, we can just take the first 25 in each list, and that will be the top 25 tokens. So it's that, and then we can calculate the tokens and the counts for the first one by taking the first and second elements of the tuples here. And then we do this for the second document as well. It's exactly the same, except this is for the first document and for the second document. Okay, now we're going to calculate the overlapping tokens. So if you look at this list of tokens here for Hamlet, for the first document, you have Lord, King, have, come. Here in Macbeth, again, we've got have, king, come. Right. So we have a lot of overlapping tokens in the 2. So we want to calculate those overlaps, which tokens are overlapping. So we're going to do that if we'll take top 25 one. So these are the tokens from Hamlet. So we're going to take the tokens in Hamlet and we'll return that to an overlap, to a list, if the token is in top 25 of tokens too. So this means it's a token in the first document. If it's also a token in the second document, we'll take the tuple and we'll, and there are actually 13 tuples, 13 of the 25 tokens do overlap. So, and these are those tokens. So these tokens are actually in both cases. They're in both, but here I've got, the counts here are for the first document. So then, so I'm going to separate these into tokens and counts. And there we have tokens and the tokens and the counts. Okay, now, since I have the overlap now, overlapping tokens, I can also calculate the tokens in doc1 and doc2, which do not overlap. So to do that, to take the top 25 to take the top 25 tokens, the tokens in the first document, which are not in the second document, I'm going to take tokens from the first document if the token is not in the overlapping tokens. And I'll do that the same for the counts as well. And there are 12 of those, which makes sense. There are 25 total and 13 in the overlap. So there should be 12 non-overlapping. So you can look at these. So these are the tokens and counts in Hamlet, which do not overlap with Macbeth. You can do the same thing for Macbeth. And these are the tokens, Lady Macbeth and the Knight, Macduff, Macbeth. So these are tokens in Macbeth, which are not in Hamlet. Okay. So now I want to create a word cloud of top 25 tokens for the two documents together. So we're going to do the same thing as last time. We'll construct a pandas data frame. Here we're going to have 3 colors. So I'm going to have red for doc 1 only. This is, in my case, this is Hamlet. I have blue for doc 2 only. This is Macbeth. And I'll have purple if they overlap. So I'll save that. You can choose colors here, whatever colors you want. I'm just picking purple as the overlapping color because that's what you get, when you intersect red and blue. Okay, so I'm going to construct my color columns. So for my first document only colors, it will be red. Times however many tokens are only in doc 1. This should be 12. And then for Macbeth, it'll be blue if the tokens are for the number of tokens that are only in the second. And for the overlap, it'll be purple for the length of the overlap, which is 13. So create that. Same thing, same idea with the URL. These are all just strings. So you probably don't need to do that anyways. Okay, now I'm going to create 3 data frames, one for the doc1 only, one for doc2 only, and one for the overlap. And notice each of these have counts, tokens, colors, and URL. Okay, so we can look at these real fast if you want to see. So that one, these are the Hamlet tokens, all red, right? These are the tokens which are only in Hamlet. And here, these are that two, these are the tokens which are only in Macbeth. These are blue. And for the dat overlap, these are the 13 tokens which are in both documents, and I've coded those as purple. Okay. Now I'm going to concatenate. I'm going to stack these on top of each other, dat1, dat2, dat3. So I'm going to use a pandas pd.concat function. And the parameter here is a list of the data frames that I want to concatenate. Dat1, dat2, and dat overlap. I just want to kind of add these 3 together. We'll do that. And that looks like this. I'm just stacking the 3 data frames. So here's the Hamlet one, here's the Macbeth one, and here's the combined. Right? The data types are the weight is an integer, and then these other 3 are strings. Okay, so this is all we need for the word cloud. So I'm going to save this out. And if we go into the file, notice I saved it into the results folder. So here are my results. It's the data, it's this task 4 word cloud data. So this is a CSV file, which is, I printed it out as a CSV file, not as an Excel file, because wordclouds.com requires a CSV file. So here it is. And that's the file we need to enter into word clouds. So here, I've already done this, so it's going to give me the same. But so to do this, choose the word list, import from CSV, right? So I would drop this CSV file, task 4 word cloud data here, render it, choose your shape, whatever. Right. So if I choose the crown, so, and here you can see the combined words are purple. The words for Hamlet are in red, right? For example, Hamlet is in red, and the words for Macbeth are in blue. So, and then you save that out as an image. I've already saved it here as task 4 word cloud combined. So I saved it on the map of Denmark, I think. So there, again, the purple are the combined, the blue is Macbeth, lady, time, the Macbeth, night, and the red are Hamlet. Okay, so that's the word cloud. Now we want to create bar plots, just like last time, except we want to color for each document. If the tokens are overlapping with the other document, we want to color those purple. And if they're not overlapping, then we want to either color them red or blue. So here, I'm going to create the data frame for the first document will be that one, which is the tokens just for, which are the first document only and with the overlap. And then here, the second document with the overlap. Can do that. So dot one all, these will be these should be 25, right? These are the 12 tokens in Hamlet, which were unique or not overlapping, and then the 13 tokens in Macbeth, which are overlapping. So that one all is fine. There's a problem here with that two all. Notice that, okay, so these are the Macbeth only keywords and the combined keywords. There's one problem here, which is that these counts for the combined ones, these counts were actually taken from Hamlet and not Macbeth. So these counts probably would be wrong and are not the same for Macbeth. So actually this overlap, that overlap is not going to work for the second one. So I'm going to pause and fix this. Okay, so it's got a little messy, but the code should work. So for the first one, we'll do what we did. We'll combine the that one, which is doc one only, and data and the overlapping data. But we have to correct the overlap counts for the second document. So here I'm going to create a list of tuples called overlap two. Again, and here it's going to be, we're just using the code from above, but here we're taking tuples from the top 25 of the second document if the token is contained in the top 25 of the first document. And the benefit, I mean, the reason why we're doing this is because we need the counts. In these tuples, if you see, the weights here are appropriate for the second document. So the token, the overlapping tokens for two, we don't have to calculate because we already know that these tokens are the same tokens as that we calculated before. But what's different is that the counts for these tokens are different in the second document. So if we run this, right, and you can compare this with the overlap tokens and counts for the first document, right? And you can see this list of tokens and this list of tokens are actually the same list, but they're in different order. They all contain the same 12, 13 items, but the counts are different. Okay, so, which is fine. Okay, so we've created the non-overlapping and overlapping tokens for the data set for first document, and now for the second document, we're going to create the data frame for the overlapping tokens for the second document, and then we'll take the non-overlapping plus the overlapping. Now notice this that overlap, I have the two here, right? This is the new data frame for the overlapping tokens for the second document, and we'll concatenate those. And then if you look, we've got the Macbeth ones, and we've got the overlapping ones, but now with the appropriate count for the second document. Okay, but these are not sorted. We want to sort these because we're going to put these in a bar plot now. But you know, these weights are not sorted. So let's sort them, and we'll reset the index for each of these. So we do that for dot one data frame, or for the first document data frame, and for the second document data frame. And now, if you look at for the first document. Now the weights they're sorted by weights. And if they're overlapping, they're purple, right? And if they're not overlapping, they're blue. So, oops, sorry. So this is the list for the first data frame, for the first document and for the second document, right? And not overlapping, overlap. So not overlapping in the second document are blue, overlapping are purple. Now, okay, so they're all sorted, and now we can make the two plots. So here I have code for the first document. I use the bar plot bar. The data is going to be the .1 all. The name is going to be doc1 name, and the color is red for the first document. And actually, I can, yeah, I can actually, well, let me see that. And then, so for the bar plot here, the words, these are the words from bardat, right? So let's look at bardat real fast. Actually, it's going to be this .1 all, right? So the words are the tokens, the weights are the frequencies, and this is the color. So we put in the tokens names, we put in their weights, which are the frequencies, and the color here is not a single color now, it's actually that column, the color column, which is going to differ from between the ones which overlap and the ones that don't. So this is, the x-axis is tokens, the y-axis frequency. So this will be the top 25 tokens in bar name, which is the first document, which is Hamlet. And then I've created this is for the legend here, Hamlet and Macbeth, Hamlet only. So when we run this, it's going to save this file to results, task 4, top 5 bar plot. Doc1 name is Macbeth, Hamlet. And this is the top 25 tokens in Hamlet. So these purple ones are the Hamlet and Macbeth, and the red ones are only appearing in Hamlet. Yeah. And we can do this again for doc2. Here the data is that2, the bar name and the bar plot name is doc2 name, and the color is blue. And everything else is the same here. And we're saving this again to task 425, top 25 bar plot for the second one. So I'll run this. And here you can see same tokens, the overlapping tokens, but not all in the same order. So here you have Lord, King, have come. Here you have Lord, King, have come. Oh, thou shalt let. You have shall. Thou is down here. Let. And then notice here, Macbeth and Vipandi, Macduff, yet these are in a different order. Here you don't have Hamlet until here. Good. So okay. So notice like Macbeth, there's a Lady Macbeth is a main character. So so Lord King have come, let shall thou good thy enter would make. These are overlapping ones, and then the ones which are unique are like half time, Macduff, and of course the Macbeth. So I don't want to make too much of it, but this is just showing you how you can differentiate tokens in overlapping documents. So these are saved here, 25 top 25 bar plot Hamlet and Macbeth. So these are the files that you'll upload, the two bar plots, the combined word cloud, and the code. So I'll update these now to reflect the changes that I made, and that is it for task 4.